Welcome to KU Pathshala, a novel initiative of the University of Kerala to archive educative videos. CLIF is taking part in this venture wherein we are exposing the instruments being housed in the CLIF campus for the benefit of people who want to use the facility for their research purposes. The facility is managed by qualified technicians, highly trained, as well that governed or managed by faculty who are all experts in the field. The idea behind housing all the instruments under one roof is that not only that you will be able to use the instrument, but also get the feel of how exactly an instrument is functioning. For that matter, we are encouraging people to come to CLIF while their samples are analyzed so that they will be able to understand how the instrument is functioning to get the desired results. We have qualified faculty as well as outside experts who will be speaking during the video filming on the application value of each instrument being housed in this. The central instrumentation facility, which is being housed in the Karyutam campus, has got about 21 equipments, high-end equipments, being supported by different organizations in the country. I'm not going to the details of the functioning of the instrument as is going to be demonstrated in the videos. So I welcome you to view the videos, and straight away we see the videos about the functioning of the instruments which are housed in the CLIF campus. Thank you very much.
Hi, I'm Dr. Saja, Assistant Professor in the Department of Biochemistry, University of Kerala. The Central Laboratory for Instrumentation and Facilitation, CLIF, in our university has LC-MS facility. LC-MS is a powerful instrument with wide applications. It is basically the coupling of mass spectrum to liquid chromatography. Here, the physical separation of liquid chromatography and mass analysis of mass spectroscopy are combined. So, we are getting the resolving power of liquid chromatography and specificity and sensitivity of mass spectroscopy. These two techniques are joined by an ionization source interface. ESI and APCI are the commonly used ionization techniques. In CLIF, the instrument has both ESI and APCI. LC-MS is applied in many industries like pharmaceuticals, biopharmaceuticals, forensic, food and environmental sector. Also, it has wide application in research for the identification and quantification of analytes. Let's have a look at the clinical biochemistry applications of LC-MS. This instrument can be used for biochemical screening for genetic disorders. For example, a number of marker amino acids and acyl carnitines are measured in dried blood spot for screening a wide range of inborn errors in metabolism. Newborn screening strategies have also been developed for galactosemia, sickle cell anemia, and lysosomal disorders. This instrument is also used in therapeutic drug monitoring. Earlier, high-cost immunoassays were used for the therapeutic drug monitoring, and this was replaced with LC-MS assays. This instrument is used for the analysis of aminoglycosides, antiretrovirals, and anti-cancer drugs. The capacity to multiplex LC-MS assays help to measure several drugs and metabolites in one run. This instrument is also used to assay vitamins and related metabolites. LC-MS assays for 25-hydroxy vitamin D3 and 25-hydroxy vitamin D2 in serum and plasma have been developed using ESI and APCI. LC-MS assays for both fat-soluble vitamins such as vitamin A, vitamin D, E and K, and water-soluble vitamins such as pyridoxine, riboflavin and folate vitamins are also available. The total homocysteine is an indicator of the risk of cardiovascular diseases, and LC-MS assays have been developed for quantifying the plasma total homocysteine level, which gives an indication of cardiovascular diseases. And LC-MS assays also used for the measurement of steroid hormones. It is very difficult to measure the low testosterone and dihydrotestosterone levels, which is found in women and children using conventional immunoassays. This leads to the development of several highly sensitive LC-MS assays, which provide reliable measurements in these groups. Multiplexed assays have been developed for various steroids. LC-MS assays will be most beneficial in the clinical biochemistry laboratory when used for multiplexed and screening type assays. Here, the additional information obtained justifies the cost of instrument and operation. Thank you.
Hi, I am Shamna, Technical Officer at Central Laboratory for Instrumentation and Facilitation, University of Kerala. We have LC-MS Shimadzu triple quadrupole system. Today, I am going to talk about principle, instrument details and running procedure of LC-MS. We all familiar the word chromatography. It is a collective laboratory technique for the separation of mixture of analytes. Liquid chromatography mass spectrometry or LC-MS is a hyphenated system in which an HPLC high performance liquid chromatography is connected to a mass spectrometer. The technology involves use of an HPLC where the individual components in a mixture are first separated based on their affinity with the mobile phase and stationary phase, which is usually a silica-based column, that is C4, C8 or C18, followed by ionization and separation of ions based on mass by charge ratio. The system LC-MS is supported with power supply of 230 watts along with battery backup, which ensures continuous power supply to the MS unit. We need two different kind of gas supplies for LC-MS unit. One is nitrogen gas and another one is argon gas. The gas supply involves an inert carrier gas, usually nitrogen, which carries the analyte to the mobile phase and also acts as nebulizing gas. During ionization process, we have peak scientific automatic nitrogen generator that will ensure the continuous and 99.9 purest nitrogen gas supply to the LC-MS unit.
Solvent system generally consists of two solvents, A and B. Conventionally, solvent A is LC-MS grade water acidified with 0.1% of formic acid or acetic acid if needed for maintaining pH of the silica column. Supply ions aids in fine separation of the chromatogram peaks. Solvent B involves an organic solvent like acetonitrile or methanol based on the nature of the analyte and compound to be separated. This part is pump LC30 AD liquid chromatograph. Parallel double plunger model. It is quaternary gradient support 5 mobile phase lines. The LC system is supported by pumps to generate high pressure, which helps in the separation process. Effective run can be achieved only after the pressure gets stabilized. The flow rate can be up to maximum of 1 ml per minute. Drain valve should be on only during purging time. We have SIL30AC good quality auto sampler with needle in flow path type. It contains two different sample loading tray. One tray with maximum 105 vial capacity and the second sample loading tray is maximum 10 vial capacity. Sample cooler capacity is 4 to 40 degree. This is the region where the analyte is dissolved in respective solvent. The auto sampler pulls up the injection volume from sample tray, which can be adjusted in software.
Next one is column chamber or column oven. CTO20AC column. Mainly column placed in a column oven and it is forced air circulation type. Here we can adjust the temperature to 10 degree to maximum 90 degrees Celsius. Silica based C18 or C8 columns is generally used in the LC-MS system. The pore size and dimension selected on the basis of analysis method. Next part is PDA detector or photodiode array detector. We have SPD M20A photodiode array detector. In HPLC portion, detect the components which get separated from the analyte based on its generation time and produces peak. It gathers data from the transmittance patterns with a range of wavelength 200 to 800 nanometer. Next one is communication bus module. We have CBM20A communication bus module. It is the HPLC system controller which acts as an interface for connecting the LC workstation, network client computers and analytical instruments via Ethernet. Solvent delivery units, auto sampler, column oven, detectors, fraction collectors and sub-controllers are units connected to it. This part is a valve unit. This region switches the LC system to the ionization source to the MS. Specially, it facilitates the entry of separated component of the sample from the column to enter the ionization source point, that is the first region of mass spectrometer.
The main part of our mass spectrometry is first one, ionization source. We have both ESI and APCI ionization source. Next, quadrupole mass filter Q1. It is widely used for selection of different masses. Then quadrupole collision cell Q2. It is used for fragmentation. Third one is quadrupole mass filter Q3. It is widely used for the selection of fragments. Last one is particle multiplier. It is used as detector.
This is the ionization source. Although several types of ionizations are available for analysis, ESI, that is electron spray ionization, and APCI, atmospheric pressure chemical ionization, are most commonly used. Here we are now connected ESI, that is electron spray ionization technique, that is soft ionization source, since relatively little energy is imparted to the analyte and hence little fragmentation occurs, generally used for polar and thermolyable compounds.
The method generates ions from solution of a sample by creating fine spray of charged droplets. A solution of a sample pumped through a fine charged stainless steel capillary needle at a rate of few microliter per minute. The needle is maintained at a high electric field, that is several kilowatts, with respect to cylindrical electrode. The liquid pushes itself out of the capillary as a mist or aerosol of the fine charged droplets. Quadrupole is a mass analyzer, consists of 4 parallel rods with a particular RF and DC. Ions are separated in quadrupole based on the stability of their trajectories in the oscillating electric field that are applied to the rods. The output is based on the ratio of RF and DC, then it will convert it to time to signal ratio.
Typically, the most difficult and time-consuming step is sample preparation. Better sample preparation technique can help you to achieve a better result from your analytes and also extending the lifetime of your column and instrument components. Solid phase extraction, solid phase micro extraction and supported liquid extraction ensure your sample are free of interferences even with the complex matrices. At the time of sample preparation, consider these following factors. First one is analyte chemistry. Polarity, charge, thermostability and molecular weight are related to analytical chemistry.
Keep an empty vial inside the weighing balance. Close the door and tear the weighing balance. Take accurately 1 mg of sample. Take the vial and add 1 ml of methanolic solvent for homogeneous solution. Sonicate the sample 5 to 10 minutes for preparing homogeneous solution.
This is the final homogeneous solution of analytes. Then use syringe filter for the removal of particulate impurities from the liquids. Now we transfer this analyte into the vial. Now samples are free from particulate matter and impurities.
Then the above sample is diluted for LC-MS analysis. Next step is keep the sample into auto-sampler tray. Load the sample tray into an auto-sampler region. Turn on automatic peak scientific nitrogen generator. Check the level of air and nitrogen to the MS unit.
Turn on all peripheral unit of HPLC system. First one LC30AD liquid chromatograph and second one auto sampler. Third CBM20A. Next one is SPDM20A. Then column.
Check the mobile phase reservoir and start purging to the LC system. 2% propanol should be placed in the pump slot to reduce the friction. Then wait for initial stabilization of instrument. Double-click the lab solution icon on the desktop. A login window appears. Enter admin and click OK in the text box. Select LCMS 8045 to open data acquisition window. Here we can edit and create new method according to the nature of analytes and method of analysis. Create a method file and save it. Then turn on pump and parts of MS unit from main window of data acquisition. Then wait for initial stabilization. After stabilization, the main window shows LC ready, PDA ready and MS ready. Now the instrument is ready for the analysis. Choose real-time batch from main window. Fill sample name, sample ID, load method file, create data file and enter injection volume. Then save the batch file. Click to start real-time batch icon. Click OK. Now analysis is progressing.
The pump drives each solvent to mixing chamber where mixing takes place under high pressure. HPLC analysis uses isocratic or gradient dilution. On isocratic mode, the mobile composition remains constant throughout the procedure. Whereas in gradient mode, the mobile phase composition is changed during the separation process. After loading the sample, the valve is switched to the inject position. The flow delivered by the pump flows through the loop, forcing by the sample ahead of it, flowing to the column. As compound elute from the column, they interact with the detector, that is UV visible detector, which showing an absorption spectrum in the UV visible region. Normally, deuterium and tungsten lamp are used in UV visible detector. The manner in which the final data is displayed is based on the computer in software. The number of peaks present can indicate how many compounds are in the mixture. Usually, the x-axis of HPLC chromatogram, which shows the amount of time taken for the analyte to pass through the column. Typically, the y-axis or the area of the peak is a reflection of the amount of specific analyte that present. Each component separated from LC unit entered to the ionization source via MS interface.
Different types of analysis modes are mentioned below. First one is precursor ion scan, then product ion scan, then neutral loss scan and multiple reaction monitoring or MRM. For data processing, go to main window of lab solution, then choose post run. Then open data file. Select the peak from chromatogram. Integrate the peak and the mass spectrum is generated. The x-axis of chromatogram is retention time and y-axis is intensity. Then x-axis of mass spectrum is mass by charge ratio and y-axis is intensity.
LC-MS technique can be used to analyze
forensic, environmental, food beverage, biopharmaceutical, pharmaceuticals and industrial applications.
LC-MS system combine outstanding separation resolution of liquid chromatography with the outstanding qualitative capabilities of mass spectrometry. The mass spectra obtained from these scan measurement provides molecular and structural information for eluted samples or components, which supplements the qualitative information based on retention time obtained using other LC detectors. This is all about LC-MS system. Thank you for watching this video.